Hey, hi everyone. So, welcome back to the channel and let's do some GFG problems. So, it's a part of GFG NPCI series, and today's POTD is about finding XOR of size. So, basically, we need to find maximum XOR in a subarray that is having a size of k. Okay. So, this problem is based on sliding window pattern, and we will be discussing both the approaches, brute force as well as the optimized one. Okay. So what the problem is, let's understand the problem first, and then we will directly jump on understanding the intuition, and then I will code live here only. Okay. So first of all, we had given an array of integers, okay, and a number k. Okay. So here is the k and array of integers. Okay. So we need to return the maximum XOR in a subarray that is having a size of k. So first of all, I hope you guys understand what is XOR. So XOR is a, I can say, bitwise manipulation kind of thing. Like we need to perform XOR on bits. Okay, so I will tell you XOR later in the video. So first, let's deep dive into what the question says. The question says simply, in an array of integers, we need to return the maximum XOR that is having a size of k. Okay, for example, here k is given as 3, so we need to pick these three elements and calculate the subarray. Okay, sorry, calculate the XOR of this subarray. Subarray means contiguous part. Okay, so a subarray is a contiguous part of any array. It means we need to pick elements in a contiguous order only. So first we need to we will pick first three elements and find the XOR, and whatever will be XOR, let's say some random a value will be there, and we will again pick other three elements in an order only. So like this, we need to go through every subarray that is having a size of k and find the XOR. And whatever will be the maximum XOR, that will be our answer. Okay. So let's see the constraints as well. So the array can go up to size of 10 to the power 6 order. It means we cannot do 10 O of n square type of solution, because that will give us TLE, okay, runtime error. And a maximum element can be of size 10 to the power 6. Yeah, it is in range of integer. It means we can use int. And k is can be up to size of array. So we can say k can be go up to 10 to the power 6. So 10 to the power 6 or is of order of k as well. Okay. So let's jump on the okay. So let's jump here, and we will see the problem once more, and we will make our intuition. Okay, so let's take an example. Okay, so we have given, let me mark this as POTD GFG. Okay, so we had given an array. Okay, and the array contains integers. Let's take any random example, 2, 5, 8 and 1, 1, 3. Okay, and let's take k as 3. Okay, let's take an example with this input. Okay, so in this problem we need to find a XOR in every subarray that is having of size 3. So first we will check this subarray because it is of size 3 and find XOR. Let's say the XOR will be a, okay, as of now. Then we will check another subarray that is having size k is 3. Let's check, let's say the value of this XOR is the value of XOR of these elements is b. Again we will pick three more elements in a subarray and find the XOR. Okay, let's say it will be of 3. Okay, and last three elements, let's say the XOR of these three elements is d. So what we need to do is that now we need to find maximum among these a, b, c, d. We need to find maximum among these subarray sub XORs. Okay, so whatever will be the maximum, that will gonna be my answer. Okay, now let's understand. I hope you guys understand subarray. Subarray nothing means contiguous a contiguous part of array. Contiguous part of array. Here it has told that we need to check for 3 length subarray. That's why I'm picking every time a k length subarray, that is 3 length subarray. Okay, let's understand what is XOR. So XOR is performed on bits. For example, we need to find 2 XOR 3. So it means uh, we need to convert, like usually XOR in the backend, XOR is running in a way like what will be the value of 2 in terms of bits. Definitely this will be my value. What will be value of 3 in terms of bits? Definitely this will be value of 3. Okay, so to perform XOR 1 0 XOR 1 1, so it means 1 0 1 1. So if both the bits were different, then we can say it is of 1. And if both the bits were same, that is 1 1, then we can say we can do as 0. Why? Because A XOR B simply means A bar B plus AB bar. What does it means? Like for example, let's take 1 0, okay, and 1 0 and XOR 1 1. So how can we write it at? First, we are performing 0 XOR 1. Okay. So, how can we write as 0? 0 as 0 bar 1 plus 0 1 bar. 0 bar means negation of 0. That means 1 1 1 plus 0 0 into 1 bar. 1 bar means negation of 1. That is 0. So 1 into 1, it means 1. Binary multiplication, simply add an binary multiplication 1. It will come as 1. Okay, so like it's a XOR it's a property of XOR. Whenever two different bits, you get different bits, then just write 1. Different bits will contribute 1 and same bits contribute as 0. Same bits contribute as 0. Okay, so yeah, this is about XOR. Okay, so we don't need to think about how, for like doing converting the number into bits and then converting it into, then doing this XOR kind of thing. We only do if we simply do 2 XOR 5 now, our compiler will automatically first convert it into bits and then do manipulation. Okay, so it's a proper, like it's a intelligence of compiler only, like it will consider these number in terms of bits and then do multiplication. Okay, so we don't need to worry about that. Simply one more thing about XOR is that if we do XOR of two same elements, it will come as 0. It's a property. Okay, in even you can check also, it's a simply we can apply this property only now. If different bits, then only 1. Otherwise, if we get same bits, then it will come as 0. It means, how can we write 2? So it means both the elements will be same, 0 0. So it will simply come as 0. Okay, so that's another property of XOR. So keep in mind, keep it in mind as well, property of XOR. Okay, then let's come on the question. So the questions first, let's discuss about the brute force approach. How can we approach it as brute force? So simply what the problem says now. So in every subarray of size k, we need to find XOR, and whatever will be the maximum XOR, we need to return that only. Okay, so what I'm gonna do is that I'm going to explore all the subarrays. How can we find all the subarrays? For int I equals to 0 to I less than n, I plus plus, and using two for loops. Simply I will run two for loops. One will run from here to here. Other will be from the same index to every subarray. For example, this, then this, then this, then this. Okay, so let's take a variable int x as a 0, and I'm going to run again another loop. Okay, that will start from whatever will be the my I, whatever will be my I. For example, if I will start from 0, j will start from 0, it will go up to k size. Okay, and then find until going to this index, it will be calculating the XOR. Okay, and if our tally, our size reaches to k, then we will simply store that XOR in another variable. And if that subarray XOR is greater than our previous store, then we will update. Simply we'll gonna update that with the maximum value. Okay, so what I want to say is that just simply run another for loop. Okay, and just calculate XO equals to XO XOR whatever will be your value of J. Okay, and if how can you get the size as K? So if you are traversing, let's say 258, okay, 258,113, okay. So if you are traversing, then you can use these two pointers to, for example, let's say I start from here and J reaches up to somewhere here. So what is the length between them? Simply use this formula, J minus I plus 1. So what does the formula says? J is 1, 1 minus 0 plus 1, that is 2. So this is of size 2 simply. If J reaches up to here, then 2 minus 0 plus 1 is of size 3. So yeah, this formula will always tell you that what is the current size, what is the current size of your subarray. Okay. So if my current subarray size is equals to K, then I am going to store, let's say we have taken some another variable as maxi as 0. Okay, I'm going to store maxi. In maximum, I'm going to store maximum value every time, maxi of XO comma maxi only. Okay, and yeah, after doing this, I will close this if loop, close the second loop, and I'm going to return the maximum value. Okay. So what will be the time complexity of this program? Na? So since I is running from 0 to n, okay, J is also running from I to n. So this will be O of order of n. This will also gonna up to order of n. So O of n into n, it means it is simply of O of n square type solution. But it's a correct solution, okay, but it will not pass all the test cases because our arrays are like the maximum size of array is 10 to the power 6 order. Okay, so yep, let's do some coding. Okay, and check the solution as well. So let me take this variable int n equals to array dot size, and I'm going to take another variable int maxi equals to 0, int for int I equals to 0, I less than n, I plus plus. I'm going to take another value as 0, and I'm going to run another for loop. Why I'm taking? Because I want to restart for every subarray. That's why I'm initializing this as XO as 0. And for every subarray, whatever will be my XOR, I'm going to store it in a maximum if the current subarray's XOR will be greater than the previous one. So J equals to I, J less than N. I'm incrementing my J, and every time I'm going to calculate XOR. Okay, and if my length reaches to like my window size hits to K size, it means that if I found any subarray of length K, I'm going to store the maximum XOR among them. Maxi equals to max of whatever will be the XOR up to the previous stored maxi. So let's say we had calculated XOR from 0 to 3, and that's its value is greater than 0 because initially we had taken maxi as 0, and we found some XOR greater than 0, then only we are going to store in maxi. Okay, and at the end I'm going to return my maxi value. Okay, so for this test case it is running successfully. Let's check for other test cases as well. Okay, so since it's a brute force solution, so it will definitely give us the runtime error. Yep, so this is about the brute force solution. Let's code our optimized solution in next video.